This video is going to be part 1 of the notes that we did on Tuesday, January 26th. So before you jump into this, if you weren't at school to get this, you should go download the file and at least have screenshots so you know the problems that we're doing. But we're going to do a few notes before we jump into working into this packet. So stoichiometry, our unit, is about how to convert between reactants and products. If you have 5 grams of a reactant, how much product you can make. And before we jump into the new stuff, we need to review mole conversions because we're definitely going to use these again. And so if you need to pause the video to write down these 3 conversions, do that. But these are our old mole conversions from December, and we're going to still use them again. So 1 mole equals 22.4 liters. 1 mole equals 6.02 times 10 to the 23 atoms, or that number can go with molecules or formula units. And then 1 mole equals whatever the atomic mass is in grams. And that atomic mass comes from the periodic table. And so again, if you need to pause that to get that, do that. And so we're going to do an old problem before we jump into new stuff. So if I had 5 grams of hydrogen, how many molecules is this? So we set up problems by using our given in the equation, 5 grams of hydrogen. So 5 grams, and then you need to write your formula. Hydrogen is a diatomic, so it is H2. And then I'm going to set up a conversion to solve for molecules. Oops. Now, looking at my conversions, this is grams. The only conversion that has grams in it is this one. So I'm going to use this one. The atomic mass equals 1 mole. And so I go to the periodic table, and I'm going to do this off to the side. Hydrogen has an atomic mass of 1.008, but it's H2, so I have to multiply that by 2 because of the subscript. So really, that's 2.016. So that's the atomic mass of hydrogen. That's how many grams are in 1 mole. And I need to put that in this spot because I have this unit grams. And with dimensional analysis, you want your units to cancel out. So down here is going to be grams of hydrogen. And the number that goes with grams is again our atomic mass. So 2.016. And whatever your atomic mass is, the other side will always be 1 mole. So 1 mole of hydrogen. Now, this grams unit has canceled out. There's a unit up top, and then the unit at the bottom. That is canceled. Now we have the unit mole. The question didn't want mole. The question wanted how many molecules is this? And so now let's go back to our conversions. The only conversion that has molecules in it is the second one. So I'm going to use this conversion. 1 mole is 6.02 times 10 to the 23 atoms, molecules, and formula units. I'm going to use this one. Now, looking at how to set this up. I want the unit molecule. I have the unit mole. So with my conversion, I'm going to put 1 mole at the bottom. That cancels out the mole unit. And then on this side, I write what it equals, which is 6.02 times 10 to the 23 molecules of hydrogen. Now, that mole unit cancels, and I'm left with what I wanted to solve for, which is molecules of hydrogen. And then to type this into the calculator, all my units have canceled. I have the unit that I want. How I would type this in is do a big parentheses, 5, and then times 1, and then times, anytime you have scientific notation, put the whole scientific notation in parentheses. So I'm going to do another one. 6.02 times 10 to the 23, and close that. And if you don't know how to do an exponent on the calculator, it should be 10 up 23. And then close the parentheses again and hit enter. Now, once you do that, you should get a number. And the number you get is actually 3.01 times 10 to the 24. But that is what the stuff on top equals. Now we have to think about what's at the bottom. And so at the bottom is, you have to multiply these numbers. 2.016 times 1. Well, that's going to be the same thing. So now I need to divide the top divided by the bottom. So you multiply all of this together, and that's that number. You multiply the bottom together, that's that number, and then you divide. And your final answer is 1.49 times 10 to the 24 molecules of hydrogen. Now this was a problem like we did back in December. We are going, this unit, stoichiometry, is just like December, except we're going to add on one more conversion, and you're going to have to write balanced equations. So we're going to go ahead and move to this packet, number 1. So anytime you do stoichiometry, and so you should be looking at this. And again, you should screenshot this, download this, because I'm not going to write on this, that's too small. Anytime you do stoichiometry, the first thing you have to do is write a balanced equation. That is number 1. You have to do that first. And so our problem for number 1 is potassium chlorate undergoes decomposition. So we need to write that equation first. Well, potassium is K1 positive, chlorate is a polyatomic ion, ClO3 -1, so that formula is KClO3. If I say it undergoes decomposition, that's my only reactant, so arrow, and then chlorates decompose into a metal chloride plus oxygen. Now my metal, it's not metal, it's potassium, so really it's potassium chloride. Potassium is a +1, chloride is just chlorine, which has a -1 charge, so that is KCl plus O2. And then we need to balance, now this, remember, that's not part of the equation, that's just helping us write it. We need to balance this equation. We've got 3 oxygens here, 2 here. So I'm going to put a 2 in front of this, and then a 3 here. Now I need to put in front of KCl a 2. So that is step 1. You have to write a correct balanced equation first. If you don't do that, everything else is going to be wrong. Okay. And then let's look at problem A. It wants to know how many moles of potassium chlorate are needed to obtain 10.3 moles of potassium chloride. So we start our conversion with the number given. 10.3 moles. Potassium chloride is this, KCl. And I want to solve for moles of potassium chlorate. Now, our mole conversions. There's not a mole conversion that goes from mole to mole. There's also not a conversion that lets us go from potassium chloride to potassium chlorate. And so this is going to be the new conversion. And what we're going to do is, this is moles of KCl. When I look at my balanced equation, this 2 right here represents that when you have this complete equation, you have 2 moles KClO3 will make 2 moles of this and 3 moles of this. And so what that allows me to do, this is a new conversion, and so this is moles of KCl. The coefficient in front of KCl is a 2. So I'm going to put down here 2 moles KCl. Now this gets rid of my KCl unit, and again this 2 comes from that equation right there. Now I wanted to solve for moles of KClO3, potassium chlorate. The coefficient in front of that is a 2. And so I'm going to put that on the other side. 2 moles KClO3. Now the problem just wanted moles of potassium chlorate, which is what this unit is. So we can type this into the calculator. And then to type it in, I would do parentheses 10.3 times 2. And then that's going to get divided by 2 at the bottom. And so your answer actually ends up being 10.3 moles of KClO3. So this right here is our new conversion. And again, I got these numbers from my balanced equation. So I'm going to go back to that conversion list, and we're going to add this to it. This is the last mole conversion we have. And so I'm going to write, so my coefficient, which is the number in front of the substance, for moles of A can equal whatever the coefficient is for moles of B. And now A is going to be one substance, B is something else. And so pause this video, write that down, and now you have a list of the only 4 conversions you'll ever use in this class. And we're going to do a few more problems so you can get used to it. So that was A. B was how many moles of oxygen are produced if 5.5 moles of potassium chloride are also formed. So we start with our given 5.5 moles KCl. And this time the problem wants us to go from KCl to oxygen. Now I have moles of KCl. I can use the new conversion because I have moles of KCl to solve for moles of oxygen using my coefficients. And so looking at my balanced equation, the coefficient for KCl is 2. And so I'm going to write, because this is moles of KCl here, down here needs to be moles of KCl. So 2 moles KCl. And I want to solve for moles of oxygen. So I go to my equation. The coefficient for oxygen is a 3, and that will go up top. 3 moles O2. Now my moles of KCl cancel out, and I have 3 moles of oxygen. And moles of oxygen is the unit that I wanted. And so I just need to type this into the calculator. So I would type this in 5.5 times 3, and then whatever that is, divide it by 2. And that actually is 8.25 moles of O2. In the following videos, I'm going to work 2 more problems, or in the next video, the part 2, so you'll probably want to watch that to go over number 2 and number 3. And that's what we did in class on Tuesday.